Hi and welcome to this video where we get to see the basics of naming organic compounds. If you're watching this for the first time, this is a series where I'm breaking down the concepts of organic chemistry step by step. So you might want to go back to check out the other videos that are the foundation for what we are doing currently. So without any further ado, let's get into what we have for today's lesson. So naming organic compounds, okay, follows a set of rules, and those rules were given by a body, an organization known as IUPAC. Now, IUPAC usually or simply stands for the International International Union of Pure Pure and Applied Chemistry. Okay, so that's who they are. So now they give every organic compound a unique name, a universal identity, and a clear structural meaning. Now, what does this mean? It means that naming organic compounds is not arbitrary. It is structured, it follows a set of rules. So that whether you're in Nigeria, the United States, Canada, wherever you are, there are a particular set of rules that guide how to name organic compounds so that regardless of location, the name remains the same. That's what structure does for us. It ensures uniformity regardless of location. So before you name any organic compounds, there are a set of things that you need to be conversant with. Number one, you need to always identify the longest carbon chain. I'll be showing you how to do each and every of these things that I'm mentioning right now. You'd also be able to, or you'd also need to identify the type of bond. Is it a single bond? Is it a double bond? Or is it even a triple bond? You'd also need to identify that. You'd need to identify the functional group. You'd need to identify substituents, and you'd need to identify position numbers. Don't get confused, don't get scared. I'd be showing you how to carry this out in a moment. So when you master this checklist, you will not be afraid of naming any kind of compound again. So that being said, let's go ahead and check out the first category of organic compounds that we have and how to name them. We're starting with the basic, the most basic and the simplest of them all, the straight chain alkanes, as you can see written on the screen right now. So alkanes are the most basic hydrocarbons that we have. They contain only single carbon to carbon bonds. So you can see a carbon atom bonded to another carbon atom, bonded to another carbon atom, and it just continues on and on like that. Only single bonds throughout the structure, no double bonds, no triple bonds. And they have a general formula denoted by CN H2N 2. In other words, when you want to identify the molecular formula of any alkane, you use this formula. Okay, so for instance, if there are two carbon atoms, it means you replace the letter N with the number 2 anywhere you find it. So the molecular formula becomes C₂H₂. Instead of N, I put 2 plus 2. This becomes C₂H6. That's how it works basically. And you can see the structure over here. How many hydrogen atoms do we have? 1, 2, 3, 4, 5, and 6. How many carbon atoms do we have? 1, 2. So that corresponds to this molecular formula, C₂H6. So they have only single bonds. They have this general formula, and they use the suffix ane, pronounced as ane. In other words, when you see any organic compound having a name that ends with the suffix ane, it automatically tells you that that is an alkane that you're encountering. So there are certain steps to name a straight chain alkane. First, you need to count the carbon atoms. You use the root and then you add ane. Now, I just mentioned something peculiar, root. Let's talk a bit about it. What does it mean? Okay, so that brings us to the concept of root names. And by the way, if you're enjoying today's lesson, you want to consider subscribing to this YouTube channel. I go all in bringing amazing content, breaking down the concepts of chemistry for you day in, day out. Root names, okay, we have them, a few of them in a parenthesis right now. They depend on the number of carbon atoms that are present. Now, just like a plant depend on its roots in order to stand, every organic compound depends on its root name in order to identify the number of carbon atoms that are present in that molecule. So, what is a root name basically, you may be asking? In organic chemistry, a root name is also called word root. It is the foundational part of an IUPAC name that indicates the total number of carbon atoms that are present in the longest continuous parent chain. So, for instance, let's take a person, an individual, for instance. If a person tells you, my name is Mr. Smith, it gives you an idea of the kind of location that person would be coming from. That person would most likely be from the United States. Okay? If someone comes and tells you, my name is Mr. Adebayo, it gives you an idea that that person would most likely be from Africa, particularly Nigeria, and is in the tribe called the Yoruba tribe. In the same way, the root name tells you how many carbon atoms are present in an organic compound, tells you the total number of carbon atoms that are present. So that's what the function of the root name is for an organic compound. And here are some examples on the screen. Let's quickly run through them. It forms the base to which prefixes, okay, we'll be looking at what they mean, substituents and suffixes, are added to fully define a molecule. So here are some examples. When an organic molecule has just one carbon atom, the root name used is METH, meth, and so on. If there are two, we use eth, 3 prop. When there are four, we use but, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 dec. So here are some examples of root names that we have in organic chemistry. So now that we've seen the examples that we have, let's check out some exercises to solve, and then we'll be done for today's video before moving deeper into the concept of naming organic compounds. So we have the first example. This is an alkane, C₅H₁₄. So let me take pains to draw the structure of this compound. 1, 2, 3, 4, 5, and 6. 6 carbon atoms. Let's draw the hydrogen atoms that are attached to it. So I have 3, I have 4, I have 5, I have 6, I have 7, I have 8, I have 9, I have 10, I have 11, I have 12, I have 13, and I have 14 carbon atoms. What are the steps to name an organic molecule like this? Step number 1, count the carbon. We've done just that. There are 14 carbon, or there are 6 carbon atoms, I beg your pardon, 14 hydrogen atoms and 6 carbon atoms. So we have 6 carbon atoms. When there are 6 carbon atoms, the root name is hex. So we have the root, which is hex, and then we simply add the suffix, which is ane, because it's a straight chain alkane. So we have hex plus ane. That gives us hexane. It doesn't get simpler than that. That's basically how you name a straight chain alkane. Simple and straight to the point. So here is an exercise on the screen I'd like you to try out your hands with. Do well to drop the answer to this question in the comment section. I look forward to seeing it. So up next, we're going to be looking at how to name branched alkanes. In this one, we're going to be going all in. I'll be showing you the concepts of naming branched alkanes. I look forward to seeing you in that video. Until then, stay blessed.